Good day, everyone. I'm here to continue the topic electric field. So, in electric field, sorry. So, I've explained the electric force. I've explained Coulomb's law, both in magnitude and a vector form, and explained the electric field himself and field line. So, on this, in my previous class, I stopped at electric field intensity. So, and I divide electric field intensity at force per unit charge. So, where I said this force from Coulomb's law is F Q1 Q2 over what R square. By putting it here, we later arrive to the what K Q and over what R square. This is the formula for field in what intensity in a free space. But if it's the medium, Q1 equal to the what E naught permittivity, relative probability, and R what square. This second formula, when the charge is in what in medium, we use this formula. And for today's class, I'm going to treat electric field due to system of what of charge. Here what electric field due to system of charge. So the system of charge, you can now say what? Considering a system of many charges. So what? Considering a system of many charge, of many charge, each charge creates its field. And the net field at a point is due to the contribution of the field. Contribution of the what? Of the field generated by this charge. That's what? That you can say what? Its net field at a point is obtained by principle of Superposition. I've explained superposition theorem in what? In Coulomb's law. So for many charge, is the that be what? Electric field intensity, the net field will be what? Field sum of field 1, 2, plus up to the what? Field n. So this is the what? The superposition theorem for what? For electric what? Electric field. Let us solve this question. Let's solve 2 or more questions on this what? Electric field in a system of what? Of charge. Example. Determine the electric field intensity in the system of charge below. What is the system of charge below? You have a charge that is here we have +2 microcoulomb because this place was -5 microcoulomb. Here we have P, a positive test what? Charge. Distance between 5 and P is 20 centimeter. Distance between 2 and -5 is 10 centimeter. We are now asked to find the what? The electric field intensity in the system of charge below. See, so our test charge is what? Is P. So we are going to find the what? Our field intensity at what? At this P. So if you could still remember the step I gave you under the Coulomb's law analysis, solution, I said the first thing is what? Step what? Step 1, we say that what? Determine the individual what? Force. And I say what? To determine individual electric field, electric what? Field intensity E. Is that the case? So let us call this one what? Q1, Q2. So to know the what? Electric field intensity of what? Using for E1, using E1 or the what? KQ1 over what? R square. What's my charge Q1 here? Is 2 plus 2. So the field intensity for E1 will be this K is 9 times 10 raised to power 9 into bracket Q1 is 2. 2 multiplied by 10 raised to power -6 That is what? Microcoulomb. In everything into what? What is the distance between this Q1, Q1 and P? From here to here is 10. Here to here is 20. Add the two together, will give you what? 30. If you divide 30 by what? By 100, it will give us what? 0 point what? 3. The distance between Q1 and P here. P is the what? Is test charge. Distance between them is what? Is 30. 30 divided by what? 100. If you say what? 30 divided by what? 100, we have is 0 point what? 3. Have you now? So you now have what? 0 point what? 3. Everything what? Square. Good. The next thing that we do now is what? 0 0.3 will give us what? 9. The rest 9 goes in this, we have 2, 2. So at the end of the day, we end up to the what? For E1, we may end up for E1 should be 2 times 10 raised to power 5 Newton per coulomb. So therefore, this one is for charge what? Q1. For charge Q2, which is what? Minus 5 microcoulomb. So you can now use what? Using E1 to be E2, sorry, KQ2 over what? R square. So the E2 will give us what? 9 times 10 raised to power 9. What is Q2? You will get the minus 5. It will be 5 times 10 raised to power minus 6. Everything into. Distance between this P and 5 is 20. Divided by 100, it will be 0 point what? 2 square. It will be 0 point what? 2 what? 2 square. So it is 0 0.2 square. 0 0.2 give us what? 0.495. By pressing the calculator, we end up to what? For Q what? Q2. The Q2 will give us what? The field intensity 2, we have 1.17, 1.1 what? 7 times 10 raised to power 5 Newton per coulomb. This is what? The electric field intensity between what? Q2 and the P. But between P and Q1 is what? 2 times 10 raised to power 5 Newton per coulomb. So don't forget the rules. The step 2. Step what? 2. Say that what? Redraw the vector diagram. Redraw the vector what? Diagram. So by redraw the vector diagram, we're having this as a given vectors, which is what? Minus 5. And we have P as test what? Charge. Here we have what? Plus 2 microcoulomb. And distance here is 10 centimeter, 20 centimeter. Good. So if you want to draw the vector diagram, please have it in mind. This P given here from the question is test charge, and the test charge is always positive. The test charge is always positive. So if this P here is positive, Q1, this is the what? Q1, Q2. Q1 is positive. What happened between the Q1 and the P? You know, they are positive, positive. They are going to what? To repel each other, not attract. So what will happen now? The force, the field intensity on the P from what? Q1 will go this way. Repulsion. It will now be what? Field of what? Of P on 1. Or no, let me call it what? Field of what? P1. But look at what? Field intensity 2, which is Q2. This one is negative, and this one is what? Is positive. So the P, which is positive, always attract the what? The negative. Out of that, so the Q what? Here, Q2 goes this way. This is what? P2. See, this direction, positive, positive, the P will repel. But positive, negative, the P will move toward the negative. That's why the E2. By doing that, the step 3 say that what? Obtain the net electric field. Electric what? Field. So the net electric field intensity will be what? Look at the two fields. Are they facing the same direction? No, they are opposite direction. So when they are opposite direction, we are going to what? To subtract, not to what? To add. So if they face the same direction, we will add them together from the vectors of sum. So here now, you will subtract. Which of the two is lesser value? Here we have 11, here we have 2. So you now say what? Field intensity 2 minus electric field intensity what? 1. So electric field intensity, the net field intensity will be what? What is 2 value? Is what? 1.7 times 10 raised to power what? 5 minus 1 is what? 2 times 10 raised to power what? 5. So by subtracting 2 from 11, we are left with what? With 9.7 times 10 to the power 5. The field net will be what? 9.7 times 10 raised to power 5 Newton per coulomb. That is what? The electric field intensity in the system of what? Of charge. Let me help you to add one more question on it. Example 2. Yes, calculate the electric field intensity P in the system of charge below. Look at the system of charge given here. The first one is 3 microcoulomb. Put what? Minus 2 microcoulomb here. Let me put what? My test charge here, P. And here, I'm putting what? Oh, okay, I'm putting 1 coulomb here. The distance here, let me call it 10 centimeter. The distance here, let me call it what? 15 centimeter. The distance here, let me call it 10 centimeter. Good. So to solve this kind of question, we need to apply the same method that we use here before. The first thing is what? Solution. Oh yeah, what's the first step? Step what? 1, saying that what? Obtain the individual electric field. Obtain what? Individual electric what? Field intensity. If you look at this structure, you will name it by yourself. This is charge Q1, Q2, Q3. So you can now say what? For field E1, if you are talking of field E1, you use KQ1 over what? R squared. Please be smart. Your Q1 is what? 3. So if Q1 is 3, this K is constant, is 9 times 10 raised to power what? 9 into bracket 3 times 10 raised to power minus 6, everything over. What is this distance between 3 and P? We have 10 here, we have 15 here. 10 plus 15, we have 20 what? 25. 25 divided by 100, we give us what? 0.25. So here you now have what? 0.25 square. So by press your calculator, this with this 937.25 this, we will end up to 4.32 times 10 raised to power 5 Newton per coulomb. This is what? E1. Let us move to the second charge, which is Q2. So what happened to the Q2? Q2 will be what? K Q2 over what? R2. This distance R1, R2 square. If that be the case, what is charge Q2 is minus 2. You neglect the minus, we are left with 9 times 10 to the power 9, which is constant K, into 2 into what? 10 times 10 to the power minus 6. Everything over what? The distance between these two and P is 15. 15 divided by 100, it will give us what? 0.15. We now have what? 0.15 square. So by press the calculator, here we will end up with 5 times 10 raised to power 5 Newton per coulomb. So the next thing is what? Let us go for the third charge, which is Q3. So for the Q3, we have E3 should be what? What is Q? K is 9 times 10 to the power 9. The Q2 is what? 3 is 1 multiplied by 10 raised to power 6. Everything over what? Distance between this 1 and P is 10. Divide by what? 100 is what? 0.1. Everything squared. Your final answer here, if I'm not mistaken, is be what? 9 times 10 raised to power 5 Newton per coulomb. This is what? A. The next thing that we do now is what? You follow step what? Step 2. We saying that what? Obtain, no, withdraw. We what? Withdraw the vector diagram. By withdrawing the vector diagram, what we have? We have a straight line in this form. Where we have what? 3 microcoulomb. Here we have minus 2 microcoulomb. Here we have P as the test charge. So here we have 1 microcoulomb. Good. This is our what? Test what? Test charge is P. So, and I said this is Q1, Q2, Q3. We want to look at what? The vector diagram. First of all, consider 3 and P. I said it before that what? This test charge is always positive. 3 is also what? A positive charge. 1 is also a positive charge. If this is positive and the P is also what? Positive. What happened to the what? To the field intensity? Is it going to move to the 3 or move away? Same charge. The field intensity here is what? It will move away. If it's move away, this is what? My E1. Because it's positive, positive. Between Q2 and P, Q2 is negative, P is positive. So the P will always move toward the negative. So for the E what? 2, we have what? The P will move toward the what? Negative. Now look at this one. P is positive, 1 is also positive. So it can never possible for this positive to move to positive. It will always repel, it will move away. So the P will what? Will move away for what? E3. Yes. If you can draw your vector diagram in this form, so we can now move to the what? To step what? Step 3. Step 3, we state that what? Step 3, obtain the net electric field. Electric field intensity. What can we do for that? Okay. The net electric field intensity will be what? You can observe that E2 and E3, they are face the same direction. We add them together. That's what? E2 plus what? E3. Why? They face the same direction. The E1 face this side minus E1. So let us do the addition here. The net force, what is E2? E2 is 5 times 10 raised to power 5 plus E3 is 9 times 10 raised to power what? 5. minus E1 is 4.32 times 10 raised to the power 5 Newton. 9 plus 5, it will give us what? 14. We have E naught is equal to what? 14 times 10 raised to the power what? 5 minus 4. If I'm not mistaken, oh, 8. Sorry? Maybe I'm making a mistake here. This place is 8. It's not 5. It's 8. It's 8. You can use your calculator to confirm it for me, please. 8. Add it together, it will give us what? 17 minus 4.32 times 10 raised to the power what? 5. So if you sum it together, the net force, the net electric field, it should be what? 12.6 is 8 times 10 raised to the power 5 Newton per coulomb. That is what? The net electric what? Electric field in a system of what? Of charge. Don't forget that what? This P is always what? Positive. So I will still solve one more question on this before we move to the next aspects. Fourth questions. We are given an electron of charge this. We are given that electron of charge 1.6 times 10 raised to the power minus 19 coulomb. This electron you have here is same thing as what? Our charge Q is situated in a uniform electric field of intensity this. So our electric field intensity is 120,000 volts per meter. Find the force. Force is unknown. Acceleration unknown. And time taken to travel through this distance. And the distance, the time taken is unknown, where the distance given as what? 20 millimeter into meter, it will be what? 0.02 meter. Yes. So to solve this kind of question, the first thing that we will say we use is what? Using field intensity is force over what? Charge. Do you remember this formula from the beginning of electric field intensity? E is force over what? Over charge. So from this expression now, we can have, yes, from there, it's like we can have, what are we going to have now? Make F, so the formula, we are looking for the F. So the force, it should be what? EQ. So the force now be what? What is E? 1,000 to 120,000. If then multiply by what? The charge, which is 1.6 times 10 raised to the power minus 9. So, okay, cancel each other. 1.6 times 2. At the end of the day, 1.2. We end up to the force in Newton to be 192 times 10 raised to the power minus 14 Newton. That's the force on electric field. The next thing is what? Acceleration. And say what? To determine the acceleration A, So what? Using force equal to the what? MA. Don't forget we are given mass of electrons to be this. So when force is MA, we are looking for the A. So the A will be equal to the what? Force over what? Over mass. What is the force we get here? Is 1.29 times 10 raised to the power minus 14 over what? The mass. The mass is given here. It is what? 9.1 times 10 raised to the power minus 31. So by dividing 1.29 divided by what? 9.1. So we are going to end up to this will go up. The acceleration A will be 2.12 meter per second square. No, what of the index form? Multiply it. This I take it up, it will be plus. We end up 10 raised to the power what? 16. Yes, meter per second what? Square. That's the acceleration. And the last one is what? To determine the distance travel. Distance what? Determine the time taken. Determine the what? Time taken to the travel, which is t. So we are now use what? Equation of what? Of motion using x equal to what? Ut plus half of a t is a linear motion square. Note that what? Where u is what? 0, we now have x to be what? Half of what? At square. From this expression, what is what? Our distance 0.2. This from this expression, we can have t should be equal to square root of what? 2x over what? A. By applying that, yes, we have what? T should be square root of 2. What is my distance? Distance is 0. What? 0.02 over what? A given is what? Calculated 2.12 times 10 to the power what? 16. So by pressing your calculator, we have 1.37 times 10 to the power what? Minus 4 seconds. So this is how you can also test for the what? Electric field into what? Intensity. So the next thing is what? Is work done in a moving charge and electric potential.